Okay, so in this video, we're going to look at how to conduct hypothesis tests on two independent sample means. Now, for the independent sample means, we can base this either on summary statistics or on raw data, and the sample sizes can be very small, and the sample sizes for each of the groups, do not need to be the same. So let's look at an example. So a random sample of 50 AACC online students scored an average of 74.3 on the final exam. It is known that the standard deviation on the final exam for all online students is 5.4. A random sample of 40 such traditional students scored an average of 71.7 on the final exam. It is known that the standard deviation for the final exam of all traditional students is 6.1. Is there enough evidence at the 5% level of significance to show that there is a difference in performance on the final exam between two groups of students? Now, one thing to kind of keep in mind for this kind of a problem is here the standard deviation is known. Notice it says the standard deviation for all online students. And furthermore, it is known that the standard deviation for all traditional students. So this is an indication that what they're trying to tell us is that we have the population standard deviation. Now, again, to emphasize, z-tests are quite uncommon in practice. Usually we don't have the population standard deviations, and so then we should default to a t-test. But in this example, this does meet our requirements of large sample sizes and known population standard deviations, so we can use the z-test. So the two sample z-test, in the stat menu, if you scroll over to the test submenu, the two sample z-test is the third one down on the list. So you can get to that either by scrolling down or hitting 3 and then enter. And then when the screen comes up, you have to choose. In this example, they've given us the statistics, not the data. And so we'll scroll over to stats and make sure that is highlighted. And then we're going to enter our information for the problem. So the standard deviation for the online students was given to be 5.4. Again, notice the sigma, it's telling us about the population standard deviation. The second sigma is for the traditional students. Their standard deviation was given to be 6.1. And then we'll enter the mean of our first group, which was 74.3. And we had a sample size of 50. The mean of our second group was 71.7. And the sample size for that was 40. And then you'll have to keep scrolling down a little bit to get the last couple of lines. We're going to specify our hypothesis test. Now, if we go back to the question, it wants to know if there is a difference in performance. So a difference in performance just means we don't care whether one group is larger or smaller. We just want to know, is it different? So that would be a not equals to scenario. And then when you scroll down and select calculate, then it will generate the following screen. Now, again, this is going to be a little longer. They can actually fit on one full screen. But at the top, it's going to state your alternative, which is that the two means are not equal to each other. The z-score that you're going to get is 2.11. The p-value is 0.03. And they're also going to remind you what the means and the standard and the population sizes were, the sample sizes were for the two groups. Now, if our alpha value is specified to be 0.05, our p-value is 0.03, so that is lower than the significance level, and therefore we can reject the null hypothesis. This would indicate that there is a difference in performance on the final exam for the online students versus the traditional students. Now, if you have unknown standard deviations, then either you're using the sample standard deviation and not the population standard deviation, or you're working from data where no standard deviation is mentioned. So let's look at this example. So here we have a sample of 16 OSU students, OSU math faculty members who had a mean of 14 years of teaching experience with a standard deviation of 3.5 years. A sample of 25 OSU history faculty members had a mean of 21 years with a standard deviation of 6.2 years. Is there sufficient evidence at the 10% level of significance to suggest that the math faculty has less experience on average than the history faculty? So for this test, this is a 2-sample t-test. So in the stats menu, if you scroll over to the test submenu, that is the 4th one down. And notice that they're talking about the sample standard deviation in both of these statements here. They're not talking about the standard deviation of all the math faculty, only the standard deviation of this sample of math or history faculty. So that is our t-test. Also, 16 and 21 are lower than the threshold that we would usually want, which is 30, to even consider a z-test. Although personally, I prefer 40 as a threshold, but different books will have different suggestions for that cutoff. So we're going to select the 2-sample t-test. And again, you can get it by that in that test menu, either scrolling down to line 4 and hitting enter, or just typing 4. And then when the screen comes up, you're going to get, again, this screen where we can enter the data. We're entering summary statistics similar to the z-test example. So make sure that stats is highlighted, and then we will enter the data. The mean of the first group is 14. The standard deviation is 3.5. Now notice the ordering here on this one is a little bit different than the previous one. On the z-test, the standard deviations were entered first, and here we're entering the mean and the standard deviation together for each of the samples. So that may help you. It may confuse you at first, but make sure that you're reading these descriptors of what you're supposed to put where. But it may also help remind you of, okay, am I checking for a population standard deviation? X bar was 14 for the math faculty, 3.5 was the standard deviation, N1 was the count, which is 16, X2 was 21, that was the mean, 6.2 was the standard deviation, and their sample size was 25. Yes, 25. And then you have to select the hypothesis test. Here we're trying to see if the math faculty, mu1, has less experience than mu2. So that, again, you may have to read these very carefully when you're doing inequalities to make sure you're putting in the right information, because it's very easy to mess up the inequalities. And then in the independent case, you have 2 options to do pooled and unpooled tests. There are 2 versions of the independent test. Now, it used to be very common to do a pooled test, which is going to assume that the standard deviations of the 2 groups are approximately equal. And then there's the unpooled test, which allows for the possibility that the standard deviations are different. It is generally safer to pick the unpooled. So pooled equals no, because that makes fewer assumptions about the data. And here we can see that the standard deviations are 3.5 and 6.2, which suggests that one of them might be at least twice as big as the other one, not really suggestive of the fact that they're the same. So select pooled equals no, and then finally scroll down to calculate in order to get the output. Now, the output, again, it's going to take a little bit more than one whole screen to print out, because at the bottom it will print out your mean, and your standard deviations again, as well as your sample sizes. But the things that you're looking for, again, is this restatement of the alternative hypothesis, the t-test, and the p-value. Now, again, notice this p-value, it has e to the -5 at the end. That means it's really tiny. That's 4 zeros after the decimal place before you get to that 2. The proportion, the p-value is not 2. The p-value is 0.00002 because of this e to the -5 at the end. It is very easy to miss that e statement at the end for students, so make sure that you're paying attention to this. This is much less than the 0.10 that we had as our significance level. It's way, way less. And so therefore we can reject the null hypothesis that they're equal, and we can conclude that this evidence does seem to suggest that the OSU math faculty do have less experience than the history faculty.